Hi everyone. In this video I am going to explain about counters. Counter is nothing but it is a digital circuit which is used to count the number of clock pulses. Suppose for all the flip-flops are registers. Suppose we are taking a counter. Counter is nothing but first of all it is a group of flip-flops. It is a group of flip-flops like your register. So register counters are the applications of flip-flops and all these comes under sequential logic circuits. Okay, we know very well all these points. So counters is nothing but it is used to count number of clock pulses. Suppose for your counter, this is your counter and you are giving the clock input which is having 10 number of clock pulses. So the purpose of counter is to say or repeat the output for 10 number of clock pulses. 10 number of clock pulses. Okay, it produces some output, a logic arrangement, a logical flow that will be repeated for 10 number of clock pulses. So how many number of clock pulses that the counter is going to count, for that many clock pulses the count will be repeated. Okay, whenever the repetition starts, then we can understand those are the count of number of clock pulses. Okay, suppose if it is a counter which is used to count this number of clock pulses 10, then it starts from 4 zeros and up to 0 1 0 0 0, after that 1 0 0 1, next it repeats 0 0 0 0. Okay, this is 0 1 2 3 and so on, like that 8 9. After that, whenever the 10th clock pulse comes, it again goes to 0. That means it counts the number of clock pulses from 0 to 9. 0 to 9 is nothing but total number of clock pulses are 10. Okay, so whenever a new clock pulse, that means 10th clock pulse occurred, again the count goes to initial state 0. This is the way how the counter is basically working. Okay, so counter is used to count the number of clock pulses. Very important. Remember, counter is nothing but it is used to count. Counter we know it is used to count, but it is used to count the number of clock pulses here in our digital circuit. Okay, and another thing is, I told you it is a set of flip-flops like your register. It is a set of flip-flops because whenever I am saying 10, 10 means it needs 4 bits. 4 bits to represent 10 in the digital format. So 4 bits involves each bit will be stored by one flip-flop. So definitely we need 4 flip-flops. So likewise, depending on the number of clock pulses, the number of clock pulses is going to be dependent. Okay, similar to the registers. It's a set of or group of flip-flops. Okay, and another important point is so counter can also be used as a frequency divider. Counter also be used as a frequency divider. Okay, that means if input is having frequency 10 megahertz, then output will be 5 megahertz. Like that number of how many number of divisions we are going to do, that frequency will be going to be divided. Okay, if it is half, then it will be 5 megahertz, like that. Okay, so counter is also be used as a frequency divider to obtain waveforms with frequencies that are specific fraction of specific fraction of clock frequency. Specific fraction of clock frequency. That means sometimes we are having a clock frequency with an amount, but we need a fraction of that particular clock frequency. Then we are going to use this counter in front of the digital circuit. Suppose see, we are having a digital circuit here. This digital circuit needs a clock pulse which is having somewhat a fraction of 1 by f of the clock frequency. Then we are having a clock frequency with this clock. Then we need a counter between this digital circuit and the clock. Hope you understand. Then this clock frequency will be multiplied by this fraction amount 1 by f. Then the output of this clock pulse is given to the digital circuit. Hope you understand what is the purpose of counter as a frequency divider. Okay, now the important and interesting thing is counters are divided into two types. Counters are of two types. So two types are there. What are they? Asynchronous counter. Obviously the second one is synchronous counter. So counters are of two types. One is asynchronous counter, another one is synchronous counter. The name clearly tells that. What do you mean by asynchronous and synchronous? Asynchronous means we are not giving a single clock pulse to all the flip-flops. Suppose if I am having, just by the name I am explaining, I have a detailed differences. I will explain them. Before that, just I am having a counter, asynchronous counter, and here I am having synchronous counter. In asynchronous counter, let us consider 4 bits of information. That means we need 4 flip-flops. Okay, so all these are flip-flops. So a group of flip-flops is nothing but a counter or a register. So the output of first flip-flop Q is connected as the clock input for the second flip-flop. The output of second flip-flop again is connected as the clock input for the second flip-flop, and this process will be repeated for n number of flip-flops. How many number of flip-flops you are having inside the counter? And this is the original input, and this input will be a mixing of different circuits, or it may be depending upon the operation. Okay, hope you understand. The output of first flip-flop drives as the clock input for the second flip-flop. But whereas in the synchronous counter setup, consider the same number of flip-flops here also. Consider here also 4 bit of information. Now the clock input for all the flip-flops is common. The clock input for all the flip-flops is common because they are synchronous. Synchronous means at a time. So at a time, and what about the flip-flop here? This is the original clock input. Okay, in a synchronous counter, the original clock input that will be applied only for the first flip-flop, and remaining flip-flops are operated the clock pulse from the output of previous stages. But whereas in the synchronous counter setup, the clock input, which is the original input, that will be given to all the flip-flops commonly. Okay, at a time. That means whenever a rising edge or falling edge occurs at a time, all the flip-flops are activated. Okay, but here there is no such type of setup in the asynchronous counter. Okay, let us see the detailed differences between asynchronous and synchronous counters. So asynchronous counters, synchronous counters. asynchronous counter and synchronous counter. First one. So flip-flops are connected. Flip-flops are connected in such a way that the output of first flip-flop drives the clock input of second flip-flop. And this repeats. As I told in the previous slide. Now here there is no such arrangement, but all flip-flops are having a common clock pulse. Because it is synchronous counter. All are activated at a time synchronously. All flip-flops are not clocked simultaneously. That means the meaning of this one is all flip-flops are not clocked simultaneously, but here all flip-flops are clocked simultaneously. Next, design and implementation is simple. Design and implementation is simple here in asynchronous counters, but whereas here it is a complex task. Complex or tedious task. What is that? Designing part. Designing part is difficult in synchronous counters. And the drawback is in asynchronous counter, it is slow because all are individually clocked. Speed of operation is low, but here it is speed compared to asynchronous counters. Because, can you tell me because all flip-flops are activated at a time simultaneously whenever the clock pulse occurs. That means the propagation delay we can simply count with the propagation delay of the first one flip-flop. Okay, the propagation delay is equal to propagation delay of counter, total counter, synchronous counter. Propagation delay of one flip-flop. Okay, if you calculate the propagation delay of one flip-flop, that will be equal to the propagation delay of the entire synchronous flip-flop. That is the advantage of synchronous counters. But whereas in the asynchronous counter, as the number of bits increases, that means the number of flip-flops increases, the delay also increases because they are individually clocked. Okay, so these are the main differences between the asynchronous and synchronous counters. In the next video, I will explain about the ring counter and Johnson counters. Thank you.